Hello everyone, welcome to Tech Talk session 41. This week is more or less a continuation from last week. Last week, if you recall, we had ABB on. We were talking about the ultra-fast earthing switch, which is an active arc flash mitigation technique. This week, we have Tommy Chau with us with BS&B, and we're going to be talking about low burst vents and how we handle arc flash mitigation by venting the high pressure buildup inside the enclosure out an exhaust vent. We use a an vent that's commonly used in the industrial environment where dust explosions are common. So Tommy will be speaking to us about that. So I'm going to flip over to the video that we showed last week just to give a precursor to this tech talk, just to show you arc flash events are very strong high pressure events that happen within the system. It can flip the enclosure doors right off the equipment, and if somebody is standing in front of it, they can get burned, they can get hit by the door, and it can be a pretty bad situation. So one way to mitigate arc flash hazards is to vent the high pressure inside the enclosure to a location where somebody might not be standing, and we would call this a safe zone. And we use a low pressure vent to do that. So I'm going to flip over to the presentation for a moment and kind of go through a couple details. Today we're going to be doing low burst pressure vents with Tommy Chau. Remember Tech Talk Session 5, we talked about minimizing arc flash events within metal enclosed capacitor banks, harmonic filter banks. There's a list of 30 items to think about when you want to reduce arc flash hazards with metal enclosed cap banks. One of the key ones is let's not have the event in the first place. Let's design equipment that doesn't fail. And that's what our session 5 was about. Session 40 last week, the ABB ultra-fast earthing switch, was another really good tech talk where we talked about active arc flash mitigation. So we got a couple of other short videos we're going to show, and we're going to talk about this passive technique of arc flash prevention. Oh, and don't forget, PDH contact hours. Send an email to either Matt or myself. We'll get you that certificate at the end of this tech talk. And remember we were talking about eliminating arc flash events. First of all, design equipment that doesn't fail. There's lots of things you can do. You can increase the in-post level. You can do more testing to make sure it's designed properly. You can insulate bus bars. You can put current limiting fuses in there. You can speed up protection. You can put the ultra-fast earthing switch in there. And then finally, there's a possibility of putting passive technique of actually sending the arc out the back of the enclosure. So, and that's what we're talking about today, a low burst vent. And I actually have one here to show you what it is. But this is what Tommy Chau will be talking to us today about. But we put these on. And what's interesting with this equipment is that this thing will open almost like a sardine can. And if you think about it, if this thing opens up, it's a clear exhaust, a clear opening of the arcing event within the enclosure. So this is something that's used in the environment where there's a lot of dust. And dust explosions, we will show you, can be quite severe. This is a name tag device. It's got a lower and an upper maximum pressure by which it will open. It's certified to open. So a lot of times manufacturers are developing their own venting system, and it's not a certified or name-plated type device. So this is something that Tommy Chau will be talking to us today about. It's quite interesting. Here's an example of an arc-resistant enclosure that NEPSI has built. Here you can kind of see that we have put on top the release area where the arc will exhaust out. You can note here that we have intake vents here, and these things also act as exhaust vents. And the premise behind this is if there's some type of arcing fault within here, you're going to get a very fast pressure buildup. The inside of the enclosure is going to get very hot, and that gas must go somewhere, and the objective here is to expel it out. The space in between these enclosures, you can see these are facing the opposite direction, would be considered a safe zone. So this is the concept that we're talking about today. In this project here, we did not use these low burst vents. We developed the vents ourselves. But we decided to take it one step further. Our newer designs, we use these low blast vents. And the reason we do that is that they clearly open. Okay, the whole area opens up. It provides a better pressure release. And this design here, we still have louvers and things that can block the release of pressure. So the objective here is we want a clear opening. We want the pressure to leave. We don't want a door to get blown off into somebody. Okay, so there are some standards in the United States. C37.20.7 is a testing standard, and there's different types of arc flash enclosures, a type 1, a type 2, and in this case, that enclosure you're looking at here is a type 1D SRSL, which means that we can stand on certain sides of the equipment, but not on all sides of the equipment. The thing about this standard is if we want to certify the equipment for arc resistance, it means we have to send out the equipment to a testing lab, okay? And the reality is that we can't do that. We cannot build and design a custom piece of equipment, and every metal closed cap bank and harmonic filter bank is custom. They are not standard off-the-shelf devices. Not like switchgear. Switchgear is almost off the shelf. You buy it, it's got a rating, it's got the same footprint each and every time. Our systems are different each and every time, depending upon the megavars of the system, depending upon the tuning points, and depending upon the switching device inside. The inside volume changes each and every time, which means that we can send one item out to be tested, okay? The next item that we build, the next will be different, and it will be a different inside volume, which means that the standard or that test that we did on that one piece of equipment would not apply to the next. So we can say that we're never going to have a certified piece of equipment because it's cost prohibitive. It requires a destructive test. We have to blow it up to show that it can pass the standard C37.20.7. So if we can't do the test or the customer's not willing to pay for the test, well, what can we do? One of those things we can do is we can put these low burst vents in. That's a way to try to get to a piece of equipment that is safe. We can also insulate the bus bar, increase the BIL, put faster protection in, put the ABB ultra-fast earthing switch in. There's a lot of other things we can do, and that's what we do at NEPSI, is we're trying to approach this certified piece of equipment without actually certifying it. So anyways, without, I guess we'll continue here, or we'll just continue here. This is what we're using. It's a vent safe from BS&B, and so today we have Tommy Chau with us, and I'll bring him on now to talk with us. Hey, Tommy, how you doing?
Good, good. Thank you, Paul. Thanks for that introduction.
Yeah, thank you for coming out to our Tech Talk to talk about your product, this low burst vent system. This is a system that's widely used in the industrial marketplace where there's lots of dust and dust explosions, right?
Correct, yeah. We typically protect dust explosion with explosion relief panel.
Okay.
And we do a lot of it per NFPA 68 in terms of the net relief area required per that piece of equipment.
Okay.
So we do sizing, and obviously to determine how many explosion vents you need, what size, and the burst pressure, and so forth.
Yeah. I want to show a video in a second of a dust explosion, because it's very interesting to see a dust explosion and compare that to actually an arc flash event that I showed at the beginning of this Tech Talk. But before we do that, why don't you present who you are and who BS&B is?
Yeah, thank you, Paul. Yeah, my name is Tommy Chau. I'm with BS&B Safety System. I have been with the company now for over 30 years now. This is my only job I have out of school. BS&B Safety System is based in Tulsa, Oklahoma, and we are the manufacturer of explosion relief panel.
Okay, great. All right, so I'm going to show this this video here of actually a dust explosion, and let me show this. So on this actually, and I think you can see it too, Tommy. This area here is actually the blast vents. These are the blast vents that are sold by you guys.
Yeah, you have like actually 5 on the top and 5 on the bottom now. Looks 10 panel altogether.
Okay, I'm going to play that back just for a moment. So you can see that this is a pretty significant explosion. It's dust, right? It's just dust that's causing this explosion.
Correct. There's a combustion of dust, yeah. Combustible dust can cause that.
All right. Okay. So why don't you maybe present some of your material here, and let me get your presentation up here. All right, here we go. And I will, if you just tell me to move on with each slide, I will move on with each slide.
Yeah. Again, my name is Tommy Chau. I'm with BSB Safety System, and thank you for the time today. We are the manufacturer of relief panel, and the company is based in Tulsa, Oklahoma. And my detail is on the presentation there. Okay, so to have an explosion, there are 4 components that come together. So you have the actual dust or the product itself, which is the fuel. You have to have oxygen, ignition source, and then confinement. Confinement is the equipment itself, the dust collector, the silo. So thanks. Okay, so in the event of a deflagration, the explosion event will minimize the damage to your equipment. Just because you have explosion panel doesn't mean you won't have an explosion. Explosion event will activate and minimize the damage to your equipment.
And Tommy, I think it's worth commenting, that's a whole silo, right, is what's blowing up there?
Correct.
So if you don't give a place for the pressure to go, an exhaust area, what you get is the whole thing fails. The whole building might fail. If it's a building, if it's a silo, the whole silo fails. And if it's a piece of switchgear or a metal closed cap bank or a filter bank, then the whole enclosure will get damaged and fail. And that's kind of what these things do.
Correct. It's a low pressure device. Okay, so again, explosion panel will mitigate and minimize the damage to your equipment in the event of a deflagration. Typically, when you have a deflagration, it's due to some manufacturing operation, handling and of the equipment. It's when you have air mixed inside the product, and you can have an ignition, and then you have the deflagration. So typically, it could happen during operation and handling of the equipment. Explosion panel are not considered to be the same as an overpressuring device. It is not intended to use in like a full liquid application, particularly full liquid liquefied gas. So it's not for protection of those type of application like runaway reaction. Okay, so in a detonation, it is very, very powerful. A product that detonates, typically we do not get into it because it happens so fast. The explosion vent cannot open fast enough in a detonated application product. And an example is like gunpowder. Is something that we do not get into protecting because it just happens so fast. Okay, here is a good definition for different information that we normally will need to do the NFPA 68 sizing calculation. So from the bottom up is the type of dust you have or type of gas. The nominal burst pressure of the panel is the P-stat, P-S-T-A-T. The P-RED is the 2/3 of the maximum ultimate strength of your equipment. And the P-max is a pressure that your equipment can see if you do not choose not to protect it. So you have a KST value, which is a index for that particular dust, that can how explosive it is. The maximum pressure, the Pmax, is that product can see if you do not protect it with explosion vent.
Hey, Tommy, maybe maybe I can comment here a little bit too. So Pmax,
Sure.
Pmax is the maximum explosion pressure during contained explosion of the particular flammable substance. So whatever, basically this is how much pressure you're going to get inside the enclosure for the explosion.
Correct.
For our case, it would be the arc flash event causes some type of maximum pressure inside that enclosure. The P reduced, the P red, in other words, the P reduced is the maximum internal pressure equipment during the venting. So if we had applied this this low burst vent into our system, we're saying, hey, the pressure is going to rise to that value, basically, to that reduced value.
Yeah. And below the period is the activation pressure of the explosion vent. And then on the next slide, you have the anatomy of the explosion.
Yeah,
of an explosion.
so
Yeah.
P-stat, I think, is actually one of the values on your nameplate. Am I correct
Correct.
on that?
Yes, you're correct. Yeah.
And then KST is basically the explosive index, which I want to actually talk about that a little bit, which is the
Please.
rate of rise of the pressure that you get from a dust explosion. Okay, so here
Correct.
you go.
Yeah. So again, very first thing that can happen, you have some type of ignition. And the very next thing is the burst pressure on the explosion panel, the explosion vent to open. And then the earliest comment on the P-red, so that would be 2/3 of the ultimate shrink. So you want to design the explosion vent below the P-red, and then you have the very top, the Pmax value that we mentioned earlier. So the Pmax could be up to 8 to 10 bars sometimes. So you could see up to about 150 psi on the Pmax on the product.
Okay.
On some material, yeah. Okay, so explosion vent is a low burst pressure membrane, could be installed over an opening of different equipment. We put a lot of explosion vent on material handling equipment. It is calibrated and tested. BSMB, we are on the committee and we follow NFPA 68 to do sizing calculation to determine the net relief area required for the equipment.
Okay. There you go.
Yeah, so BSMB have representation on the NFPA 68 standard and NFPA 69.
So I think it's worth me mentioning to the audience that NFPA 68, 69, they all have to do with explosions related to dust and not to internal arcs.
Correct.
Yeah. So the audience should realize that what we are using here, these vents, really are intended for dust explosions. NEPSI's decided, hey, this makes sense to use these for the arc flash events also. And one of the reasons we like them is that we are able to seal off the internals of our equipment from the dust, from the environment. It's a stainless steel membrane. It's got a certified release pressure. We put it on the back side of our enclosure, and we know that when the pressure gets up, in this case, they either, I think, 0.5 is what these are rated for, 0.5 psi, 0.5 pounds per square inch. And we can calculate those forces on the walls of our enclosure, what kind of forces we're going to have. We know that the vents are open. And this is one of the things. That one design we showed that we had prefabricated our own vents, but the problem is they're not certified and we don't know what pressure they will actually activate at. So this is a way for us to say, okay, we're not able to send this out to a test lab, but let's do the best we can to make sure that the equipment is designed for to prevent those doors from coming off, for instance, or the enclosure being bent up. So that's really has been our main use for these.
Yep, NFPA 68 and NFPA 69.
Okay.
Okay, so on venting upper depth segregation, the explosion, an explosion with the combustion zone part, it can happen at less than the sonic velocity. And we mentioned earlier, detonation is something that we typically stay away from because it happens so fast. So depth segregation venting is, again, minimize the pressure inside your protected equipment, and then basically you want to direct and take all the pressure in the fireball to a safe and isolated area. Okay, NAP 68, again, explosion vent prevention system devices. So we have explosion vent, explosion panel, explosion relief vent. These are all the same product. It's just some people refer them to as panel, some people refer them to as relief vent, but they are not the same as the explosion door or explosion louver. Explosion vent, explosion panel are non-reclosing device. So not to be confused with the explosion door.
So the just to make sure we understand what you meant by that, it means that when there is an arc flash event, you have to replace this membrane. This is a device that will need to be replaced after, correct? It's not a door.
Correct. It's a one-use. Yeah. It's
Yes.
we would like to refer to them as non-reclosing device. The explosion door is a device that I believe you have to calibrate and do other tests out in the field to be able to reuse it. It is not made by us.
Yes. Incidentally, when we have an arc flash event inside the enclosure, normally it means you are replacing a lot of other parts also. It's an explosion, so there are a lot of sensitive components that actually do fail in the end.
Okay, so NAP 69 get into if you cannot vent a piece of equipment because it is indoor, and obviously explosion vent, you need to vent it to a safe and isolated area. So NAP 69 get into containment, suppression, inerting, and isolation technology. So again, we provide, BSB provide sizing calculation per NAP 68. The purpose of it, again, to direct the fireball, minimize damage to your equipment when using explosion vent. So here are some of the parameters I would require to do the sizing calculation for you. The type of dust that you have, the KST value, or the K sub G if you have the gas application. Then we talked about earlier the Pmax value, the Prad, and then the burst pressure of the explosion panel, the L over D information, and obviously we need to know the volume information of the equipment. And same as the previous slide, this one include if the equipment is close by an outside wall, short enough that we can provide a duct on the outside of the explosion vent to direct the fireball and pressure outside. It can be considered an NFPA 68 allows some sizing to include a duct link for directing the pressure and the fireball outside to a safe area. We also have we use a third lab party to do KST testing. So if you would like your product tested to determine the KST and the Pmax value, it can be done. Okay, so the industry recognized the different product on how explosive it is with a class 1, class 2, class 3 classification. So basically this gives you the KST value for different product, and it is in bar meter per second.
Yeah, so So I want to stop here for a moment and talk about KST a little bit, and I want to
Please,
first
yeah.
go to a video last week. And last week we had a video where we showed an ABB test being conducted, and let me get that playing now. And I'm just going to slide this over to where ABB provides a chart right here. This is right there. Right there. So there was an overpressure in bars. Bars are about, one bar is about 1 atmosphere, remember. And you can see the pressure buildup per unit time. Okay, so if I go back to my presentation now, I'm going to go back to my presentation just for a moment and show you this here. And you can see that the KST value that we're talking about, this is the formula for KST right here. Okay, if you were to assume that we're talking about 1 meter cubed of volume, you can actually come up with a bars per, right here, bars per millisecond value. So kind of going back to this curve from the ABB test, you can see that the millisecond, the increase in pressure per millisecond was on the order of about 0.16 bars per millisecond. The KST value, which talks about basically the pressure buildup per unit time, also the value for the worst case is ST-3 is 0.3 bars per millisecond. So, you know, when NEPSI was looking at this, we're saying, does this make sense? Does this technology make sense? Are we talking about pressure buildups that are on par with an arc flash event? Because arc flash events are very fast, and you see that first video is the door gets blown off, and you're saying, well, can a dust explosion do the same? And I think the answer to this is yes, and because we're showing here the pressure buildup versus time for a test that was done on a piece of switchgear. You can kind of see from that video that it was 0.16 bars per millisecond versus this dust values that are used by NFPA 68 are on the order of about 0.3 bars per millisecond. So this is one of the reasons we went towards using these low burst vents, is that they can be effective in reducing the pressure buildup. And although NFP 68 is addressing dust, we're kind of cross-applying it into this arc flash event and the pressure buildup in the enclosure. So I'm going to go back to your presentation, Tommy.
Oh, no problem. Thank you, Paul.
Yeah.
Yeah, so here are some of the examples for ignition short. One of the components that will cause you an application or explosion. So you have a very common static electricity is very common, and you have different, some type of chemical reaction. Sometimes it could cause a spark, and then something ignite. So ignition short. And the particle size is very important here. So think about something that's really, really thin and tiny. Obviously can ignite and explode easier versus something is big and chunky. So the smaller the dust particle, the more explosive and violent your combustion is going to become. And this is a table that provides some example for KST value for different chemical dust. So as you can see, you have a KST value on the very first one of 97 and the Pmax of 8 bar. So the anatomy of the explosion, the Pmax is all the way on the top. So it could generate up to 8 bar of pressure. So 8, times 14.5 psi. 1 bar is 14.5 psi. So that could get you up to about a little bit over 100 psi. So the idea is to be able to put explosion vent on there at 1 and 1.5 psi and have the explosion vent activate, versus having your equipment see the Pmax value, which could be 100 times the pressure of the explosion vent itself. So that's the idea of having explosion vent.
And eight bars is a lot of pressure. 8 bars
Yeah.
is eight atmospheres basically, and
Yeah.
that's a lot of pressure. 15 times 8 pounds per square inch over an
There you.
area. And if you think about pressure in areas, it
Yeah.
adds up very quick.
And as you know, Paul, we talked about this. Yeah, the common burst pressure for explosion vent is 1 to 1.5 psi. So obviously, that's the idea behind it.
And even that is a lot, right? When you think about, if you take the wall that might be, 8 foot, yeah, 8 foot,
Depending on your area. Yeah,
yeah,
correct. Yeah.
yeah, it could be quite a bit. Just a door. I mean, just do the calculation. So if we had a 4x8 door, be it'd be 48 inches. So we got 4 times 8, 4x8. That's 32 square feet. 12 times, 12 times. That's 4,600 square inches. If you just took that most basic one, you have pressure build up. You say bars, right? Well, Pmax is bar. That's
It's in
not per
bar.
square inch. But okay. Yeah, so here I'm doing this calculation. It's not making a lot of sense. So 4,600, though, square inches on a typical enclosure door. And if it's just even 1 psi, that's 4,000 pounds, 4,600 pounds on a door. And that's the point. We have our burst vents set at 0.5. We
PSI.
go with a very low value, because at 0.5 that would be 2,000, basically about 2,000 pounds of pressure wanting to pull the door off the enclosure. So we have to be reinforcing our doors to prevent that 2,000 pound force from pulling that door off the enclosure. So that's kind of the premise behind the design, the most basic premise behind it.
Okay, so KST value for different metal dust is, as you can see, is very high. Aluminum is got a KST value of 415. So obviously this is a class 3 dust explosion. So magnesium is over 500 on the KST value. So metal dust is very, very explosive. And the agriculture dust this is a very common material product we all familiar with. So we do quite a bit of work in this industry in terms of explosion vent. So we have, as you can see, different product material. Sugar dust is very explosive. Cornstarch is on there with a KST value of 202 KST value of cornstarch. So a very common product in the agriculture industry.
Okay. Hey, so Tommy, we got a question. I think it's a question directed at NEPSI.
Sure.
It's from Nick, and he's asking, are blast vents usually specifically listed on a customer spec, or does NEPSI add them based upon other factors you see during the evaluation? So on a typical basis, metal closed systems are not specified as arc resistant. It's those customers that say, hey, we want arc resistance, we want more protection for our employees, what can you do? And this is how we handle that request. We put in these low burst vents. So it's not something that we add. They do have some costs associated with it, and they need to be planned. We need to know where to put them on the enclosure. So the customer has to pick, well, what is the safe zone? And a lot of times it's on the back, but sometimes it's on the side. And that should be a no-go zone. Once you picked an area where you're going to be exhausting material, in the case of an arc flash event, you want to make sure that that area is basically fenced off so that it's a no-go zone. So it is something that we don't do as standard. They do carry cost. We think that all specifications should carry it, and if they did, then all suppliers would be supplying it, and of course we would then be happy to do it on all projects. But as you know, price oftentimes is how you're weighed against your competition. So we need to stay price competitive. We oftentimes do add it as an option, and then the customer can then choose. So good question, Nick.
Thank you, Paul. Uh, KCG value for different type of gas. For protection, propane is normally we would use for reference, but as you can see, some common type of gas on there for gas explosion. When we do the calculation, we will need the KCG value. So what is an explosion vent? So I think we've been talking a bit about this. It is a low burst pressure membrane. It is calculated, designed for an opening. So again, getting back with the calculation per NFPA 68 is how we determine how much explosion venting you need in terms of area, and then we select the sizes for the explosion vent. BSMB also provide safety frame, which is used with the explosion vent. Typically, you have to have a flange that's connected to your opening on the equipment and the explosion vent, and then you have a hold down piece that bolt the whole assembly together. So we provide either a welded type or the bolted type safety frame.
So incidentally, I'll go back to what we do here, just so the audience knows. So we have this is it's a very thin piece of stainless steel, more or less is what it is. I'm sure it's got more complexity than that because it's calibrated. But you can see we have holes along the whole perimeter of this burst vent, and we create a angle iron frame, and then we use basically half-inch bolts along the whole perimeter of this sheet.
Yeah,
and that's how we're doing it.
Yeah, and the explosive vent hole diameter is 5/8, so you got some tolerance there.
Well, I could potentially be wrong, by the way. I was assuming half here when I was looking at the hole. So they're probably doing exactly what you're saying, using the correct size bolt.
Yeah.
So
I'm sorry. I mean the hole diameter is 5/8, and then the bolt should be half an inch.
Yeah. And I go back to my presentation real quick and kind of show
Sure.
how that looks.
Okay.
And that's here. You can kind of see it here. Close up. I wish I had a larger picture, but I didn't have time to prepare today for it. But it's right there. You can see how we created that perimeter around it. And anyways, this was a LinkedIn article we did a while back, but this was all the other things we do for arc flash mitigation on top of just putting vents in. I mean, there's many things you can do. So kind of back to the next question is we're trying to prevent faults in the first place. We are doing other things as standard, those low-cost items, and then there's higher-cost items like the vent here that we can often supply.
Okay. Go to the So again, BSB manufacture a different type of panel. We have a name for all of the panel that we provide. So they are low burst pressure membrane, and typically a lot of our application, the equipment see a lot of back pressure vacuum. So we do different things with our product to withstand the normal vacuum operating condition to let the panel withstand the vacuum. So basically, a lot of our panel will withstand normal operating condition of back pressure vacuum that you have in your system. So we provide different way of doing support of the equipment on the explosion vent. So half of PSI is pretty common on big area explosion vent.
Do you ever go lower to 0.5 PSI? Is that the lowest?
We have a building panel, Paul, that can go to about 0.2, 0.3 of a PSI.
Okay, 0.2.
Yeah.
Okay.
30 to 40 PSF, power per square feet. Yeah, so we do have a special building panel that we get into on really low pressure application. So typically we use a lot of 316 material on explosion vent. 304 also is very common. And then on the safety frame, carbon steel, 304 angle, 316 angle is very common material.
Yeah, that's one of the things we like about this is the stainless steel, right? This is stainless steel,
Yeah,
and
yeah.
so
I believe
when
it's 316 stainless. Yeah.
yeah, so we don't paint it; it goes on, and we we seal up our equipment from the environment. The rain and dust doesn't come into the enclosure because it's completely sealed. This is something that when you're making maybe your vents out of raw sheet metal or creating some type of flap mechanism, and this is how other manufacturers might attempt to do this, you're still allowing those items to come in. And then the question becomes, is it really going to work after, when it's all said and done? After it sits in the field for a year or two and there's potential corrosion going on, things like that, you have to ask the question, is it really going to work? So this is why we really like this low burst vent, is because it's stainless steel and we know and feel like it's going to work. It's been certified to do so.
Okay, so we manufacture different sizes, 16 inch up to 60 inch. On the circular shape, we have rectangular explosion vent, 12 by 18, all the way up to 44.5 by 68. Now, please keep in mind these are the internal dimension opening area. So on the 12 by 18 inch panel, the outer dimension of the explosion vent is, if you're using a 2 by 2 angle, so the outer dimension would be 16 by 22 on a 12 by 18 inch explosion vent, inner dimension. Again, we get into burst pressure of explosion vent, half a psi on a lot of the bigger vent, and typically we don't get anything higher than 5 psi on the higher end of the maximum pressure on explosion vent. So half a psi, 0.75 psi, up to 5 psi. We also have temperature in terms of operating temperature. So we typically design our explosion vent to withstand the temperature, that the operating temperature inside the equipment. Explosion vent marking, I think Paul mentioned earlier, we provide a name tag on all of our explosion vent. It give you the minimum, maximum burst pressure, the opening area, the temperature. So that's all well identified on the name tag of the explosion vent. This next couple pages are questionnaire information that we would like to typically use for a customer to give us information to help with the sizing calculation and specifying explosion vent. So I got 2 pages of questionnaire information typically that I would use with customer, helping on the sizing and recommending our explosion vent. So we can email this out to anyone that will be interested in having it. Okay, so we make a single metal construction panel called the VSP, Victor St. Paul, and this is a panel that can withstand a lot of back pressure vacuum without any vacuum support. Single layer construction supplied with gasket, and it's very easy to handle. It's damage resistant. So because of the shape and the way that we make the panel, so this is one of the panels that we actually do quite a lot of with, and it's in the marketplace a lot on this panel. So the VSP panel is a thing. Yeah. So again, the sizes I think we mentioned earlier is 12 by 18 inch, all the way to a 44.5 by 68. So on a 44.5 by 68 inch panel, you have a total net relief area of 21 square feet, approximately. So burst pressure, again, 0.75 to 5 psi. We get down to half a psi if we need to on a big panel. And it is, again, it is a laser cut in a way that the panel is a non-fragmented design, so it won't come up when it activate. We have an uncut area that act like a hinge on the explosion vent. So with a single layer material piece of dome panel, the response time is a lot quicker. So you want the explosion vent to open as quickly as possible if you have an event inside your equipment. So the VSP is ideal, and it's very good because it is only a single layer dome construction. We also provide insulation on our explosion vent for insulation. Typically, we put them on the outside of the explosion vent to provide for protection of condensation and heat loss. A lot of the dairy industry customer like the insulation on the explosion vent because they do not want any product buildup inside the inside the equipment on the explosion vent material. So this insulation prevents that. We also provide explosion vent a lot actually for the sanitary market and industry. So it basically it is a sanitary gasket, FDA approved, and silicone caulking seal that we use to make the panel. So it is considered a sanitary design. So we do have this option to supply explosion vent that meet the FDA and the USDA 3A requirement. We also provide a burst sensor on our explosion vent for activation. The idea is to be able to identify if you have an opening on your explosion vent. Typically, a lot of our panels are mounted up pretty high on the equipment, so this magnetic burst sensor can provide the control room with the alert if you have an opening. Okay, so here are some of the very common equipment that explosion vent protect. We do a lot of work with the with dust collector manufacturer. Again, obviously dust collector are very can cost you an event because of the way the product is circulated inside the equipment, and then you have an event if you have a lot of dust moving around, a lot higher chance of having a deflagration, and then we protect a lot of silo, different type of conveying equipment. So bucket elevator is very common that we do explosion vent protection on. So this is just some of the application that we work with a lot actually.
You don't have capacitor banks or harmonic filters listed there, so you got to add to the list. And for those out there specifying custom electrical equipment, think about using the burst vents. These low burst vents. It's a pretty inexpensive way to provide a degree of arc flash protection for the people working on the equipment. Not that expensive, not difficult to do. You figure out an area, a safe zone, put the vents on that side of the equipment, and you got some protection for your workers. And that's really the purpose of this presentation today, is to say, think about using this on your metal enclosed cap banks and filter banks and other electrical equipment that's custom in nature, where you know arc flash testing is cost prohibitive.
This is just a cross-section view of the dust collector, and as you can see, you have the explosion vent toward the top there, and typically you want to put the explosion vent where your highest risk is going to be, which is where the dirty air is going to be. The clean air, typically you don't have a lot of higher risk, so just a view to show where typically where you will put and mount the explosion vent on the dust collector. Yeah, a sectional view, you have a lot of bag inside the dust collector is always moving around and circulating, so that is where you have the dust moving, and that could cause you a problem. So this is a cross-section view of a dust collector, so where the back out and all that inside.
Okay, we got a question from Dave, and Dave, that's a good question. Dave's asking, well, how much cost does it add to the equipment? And I'm going to say no more than 2%, but maybe more on the order of 0.5% cost on the equipment. So you're adding 2, 3, or 4 of these vents to your enclosure. It's not a ton of cost there. It's very simple to do. So I would say less than 2% for sure, probably more in the order of 1% for the equipment.
We also put explosion vent on Cyclone, and typically for explosion vent on Cyclone, we put them all the way on the top head of the Cyclone because you do not want to jeopardize the operation of the Cyclone, putting it on the body of the Cyclone. So explosion vent typically are mounted on the top head on Cyclone equipment. And silo, very common. They're very easy to protect. Typically, again, explosion vent are mounted all the way on the top of the silo because a lot of time with silo you have filling and refilling of the product. So you want to mount the explosion vent away from them. So typically on the top where we put explosion vent on silo equipment.
So, Tommy, I got to ask a question. If I'm driving down the road, when I look up at silos, am I going to see these burst vents often? How often are they used on silos?
That's the Paul. I think that's really a good question because the awareness and the understanding of how dust explosion can cause you a problem, I think it's becoming quite common now. I mean, that we put a lot of explosion vent on silo in the corn processing industry, and but again, they get back to the type of product that you have inside your silo. Obviously, if it's something that can cause and ignite, you definitely want to protect it.
Okay.
So we work very closely with the silo manufacturer to specify explosion vent when they're designing the silo. So because to retrofit and all that afterward is more challenging. Obviously, you have to cut into it to mount the explosion vent. So we try to work very closely with the manufacturer of different all the silo manufacturers, so explosion vent can be specified during the manufacturing of the silo itself.
All right.
All right.
So
thank you.
Yeah, looks like we're about finished here. Questions, you might want to get them to us soon because we're probably within a minute or two of being finished. I'll go on to what we're going to talk about next week, actually week after next. It's going to be, we're going to be meeting again on, oh boy, I had it here, the 18th. The 18th of March, we have Southern States coming on to talk about the Southern States cap switcher, and specifically the pre-insertion resistor technology that they use. And so we're happy to have them with us that week. And we're going to be going out onto the factory floor. We have some Southern States cap switchers installed in our equipment. We're going to talk about how we install them and what those switches do. And we will have Southern States with us to talk about the technology in their company. So we're looking forward to that. So next week, we are not doing a tech talk. It'll be March 18th. And don't forget to send an email to either Matt or myself, not both, for your PDH contact hours. I see some people in the chat area have said they want it. We will be able to send it to you. We need an email from you to us. And that code for today is, let me get to the slide, is 888. And yeah, there it is, 888. So just send us that talk. You can send it to me or to Matt, and we'll get you that PDH contact hour certificate right away. And I think that's it, Tommy. I think we have finished up the presentation. I think the conclusion for today is this is a technology that is not really being used in the electrical industry. NEPSI is using it. We have used it quite a few times. It seems to be sound what we're doing. We're taking a certified burst vent that's sealing off the electrical equipment from the environment, and we're looking to achieve some degree of safety. Even though we cannot go through the effort of testing the equipment in a testing lab, this seems to be approaching that direction. So we recommend that others consider this in other electrical devices also, not just cap banks and filter banks, any custom equipment. It could be rectifiers or maybe induction furnace type applications. There's a lot of different electrical applications where the equipment is custom. So think about putting this burst vent in that technology, in that equipment also.
All right.
You want
Thank
to
you
add
very much.
anything, Tommy, or are you, you good?
No, I'm good. Thank you very much for the opportunity, Paul.
Yeah, and I appreciate you coming on. Thank you.
All right. Thank you.
March 18th.